today we're talking about domain and range. Domain and range. Now, hopefully what you've been doing, taking notes in some way. So here's something I want you to add to your notes. The first thing I want you to make is a quick little table. And I'm going to put here the X and the Y. The last time we talked, whenever we did functions, we called this input and output. So that's the first thing I'm going to add to this. Is I'm going to call this the input and this the output. We input things into the X value, and then the Y value outputs things to us. And now we're going to label these also as domain and range. The easy way to remember this is that we'll never say that backwards. It's always X and Y. We always say domain and range, Batman and Robin. We never say those things backwards. So domain is always going to be the X. Range is always going to be the Y. And one more thing I do want to put in here is independent and dependent. Independent and dependent, as in the X value, the X variable is independent of the Y, and the Y value depends on what the X is. So that's where we're going to start. Let's go ahead and talk about what domain and range is. So I'm going to go over here, make a quick and easy little L graph. There's a little L graph here. I'm going to put a quick equation here as well, or a quick line like that, where this is the X value is my input, this is the Y value is my output. And I'm going to put some symbols here. Maybe you've seen these before. This is going to be a closed circle. This is going to be an open circle. And we're going to start talking about the domain and range. So here's what we're going to do first. This down here is the domain. These numbers are going to be the domain. Whatever the graph has numbers, that's going to be the domain. And then the same for the range. Over here, where the graph has numbers, that's going to be the range. So let's just go give it some quick and easy numbers. Like that would be a 1. Down here, this is going to be a 4, and then for the range, we'll do just something different, 2, and then we'll do 5, just to keep these a little bit separated. So on this graph, I said, give me a number in the domain. You could very easily give me any number between 1 and 4. And so if I said, what is the domain? What is all of the domain? I'd want you to give me like a sentence, say, what is every number between 1 and 4? And then the same thing for the range. If I said, what is the range? You can say, well, it's every number in between 2 and 5. Every number between 2 and 5, there is a value on the graph in the Y on the output. The graph has output numbers between 2 and 5. So let's talk about how we're going to write that. So for the domain is X. I'm going to start with an X. And I want to say that the domain are numbers bigger than 1, but less than 4. And that's almost it. We have one more thing to talk about, and that is the open and closed circle. The open circle, like the one we have on the right, means that it does not include the 4. It includes 3.9, but not 4. And the closed circle means it does include the 1. So what I'm going to do is I'm going to add this little line right there. And now that is my domain. My domain for this graph is 1 is less than or equal to X, which is less than 4. Or another way to say it is the domain is all numbers in between 1 and 4, including the 1. Let's do the range. So the range is going to be starting at 2, going bottom to top. So I'm going to start with the 2. It is a closed circle, so I'll say less than or equal to Y. And then at 5, it's an open circle, so I'm going to say just less than 5. And this is my domain and my range. The domain is the X, and the range is the Y. So let's do some graph examples. And the more examples we do, the easier this is going to become. So if right now you're like, I'm so confused, that's okay, you should be. But once we do a couple of these, it's going to start to make a little bit more sense. So here we go. Let's start. It's so tiny. Let's make it bigger. So here we go. I'm looking at 3 graphs. I'm going to start with number 8 here in the middle. So the domain are going to be all of the X values. So it's going to start here at -1. It's going to end here at 2. Those are all of the X values that this graph has. The way I want to write that is like this. I want to say, okay, so I see a closed circle here. So I'm going to do -1 less than or equal X, X because it's domain, which is less than 2 because it's an open circle. We don't put the equal sign. The range is going to start at the bottom. We're not going left, right. Now we're going bottom to top. The bottom of the range is here at -3. It's going to go all the way up to 6. So here I'm going to say that the range, open circle, so I'm going to say -3 less than y less than or equal to 6. Start the domain. Domain, the furthest back this goes is -5, and it goes all the way to +2. Both closed circles, so I'm going to say, okay, -5 less than or equal to x, which is less than or equal to 2. That's domain. Pretty simple there. And then the range, which we will do in red. The range starts down here at -2, and it goes all the way up to 4. Notice it goes all the way up to 4. It is not going to stop at 1. It goes all the way up until there's no more numbers there. So I'm going to write this now out as the bottom, which is at -2. So -2, it's a closed circle, is less than or equal to y, which is less than or equal to 4. And that's going to be my range. That's a 4. It's a clever board sometimes. It's not the best to use. That's a 4. And then this is the last one I want to do for this. So now we have an arrow, which I'm sure you know implies that this line keeps going forever. It's going to go down forever. It's going to go to the left forever. On my screen, go to the left. I know probably on your screen I'm pointing to the right, but I promise in reality I'm pointing to the left. So let's talk about what the domain is. So the domain, at the top of the domain, the biggest number in the domain is going to be right here at 3. And it's going to go negative forever. So how do I want to show that? How do I want to show all numbers less than 3 as a domain? I'm going to write x is less than 3, and that's it. That's it. That implies that all numbers less than 3, which includes -1,000,000 and -7 and -9.2, all numbers less than 3 is the domain. And then the same for the y. So I'll switch this over here. The top is at 7, but it goes down forever, which includes all the negative numbers. So let's go ahead and make this y is less than 7. And that's going to be the range. So only if we see two circles like this one, we had a circle here and one here. That's why I had 2 numbers. But if we start seeing arrows, I'm messing with the clever board. If we start seeing arrows, then we're only going to need 1 number. And if we see 2 arrows, which let's just pretend that was an arrow, we would say the domain is all real numbers and the range is all real numbers. That's only if we see 2 arrows going off in both directions, up and down, left and right. Let's do a couple more here. I know this is kind of hard to see. It's a little blurry, but it's okay. We can still see it. So this one right here, what's the domain? What is the range? When you see these problems, especially on the STAR test, they will give you both. They will say, what's the domain? But then they will put both domain and range in the equation or in the answer, hoping that maybe you read it wrong and you give me the wrong one. So this one is asking for domain. Number 1 is asking for domain. We know domain starts at -4 with an open circle, ends at 2 with a closed circle. So my domain is going to be C. -4 is less than x, which is less than or equal to 2. If I look at this real closely, I can see here's the range. There's the range right there. 0 is less than or equal to y, which is less than 3. There's the range. They will put both domain and range on these problems, so watch out for both. Now, I want to talk about what if it's not a line? What if it's points like this? What if it is points like this? And I'm actually going to switch this one so we can see all the answers. So here, it says, what is the range, number 7 here? What is the range of the function? What is the range? I'm asking, what are the y values? It's a fancy way to ask you, what are all of the y values? The y values can be -4, 0, 0, 2, and 4. And there it is, -4, 0, 2, and 4. And hey, look, didn't I tell you, here's the domain. And that's the range. Domain's going to be -5, -4, -3, and then 0. Oh, no, sorry, -1. That's -1, not 0. And there's a domain. Let's do the next one. Number 8, it is asking for the range. Now, here's where it gets a little tricky. The range is a single number. The range is just the number 3. The range is just the number 3 because even though there's 4 dots, they're all on the same y value. They all have the same y value, so there's only one y value, is 3. And then the domain is going to be -5, -2, 1, and 4. There's one more thing I want to touch up on. They will say, what's the domain? But then they'll put both domain and range in the equation or in the answer, hoping that maybe you read it wrong and you give me the wrong one. So this one is asking for domain. Number one is asking for domain. We know domain starts at -4 with an open circle, ends at 2 with a closed circle. So my domain is going to be C. -4 is less than x, which is less than or equal to 2. If I look at this real closely, I can see here's the range. There's the range right there. 0 is less than or equal to y, which is less than 3. There's the range. They will put both domain and range on these problems, so watch out for both. Now, I want to talk about what if it's not a line? What if it's points like this? What if it is points like this? And I'm actually going to switch to this one so we can see all the answers. So here, it says, what is the range, number 7 here, what is the range of the function? What is the range? I'm asking, what are the y values? It's a fancy way to ask you, what are all of the y values? So the y value is going to be -4, 0, 0, 2, and 4. And there it is, -4, 0, 2, and 4. And hey, look, didn't I tell you, here's the domain. And that's the range. Domain is going to be -5, -4, -3, and then 0. Oh, no, sorry, -1. That's -1, not 0. And there's a domain. Let's do the next one. Number 8. It is asking for the range. Now, here's where it gets a little tricky. The range is a single number. The range is just the number 3. The range is just the number 3. Because even though there's 4 dots, they're all on the same y value. They all have the same y value, so there's only one y value, is 3. And then the domain is going to be -5, -2, 1, and 4. There's one more thing I want to touch up on because I know it's a part of your homework. I don't have, oh, I do have it. Here it is. Oh, that's not a part of it. Let's see if there's something better. Let's do 2 more. Where'd it go? There it is. I'm going to do these 2 right here. I'm only going to do 14, not 13. Let's just do 14. What are the domain and range of the function defined by the set of ordered pair below? So I just gave you points. I took away the graph. Here are the points. What is the domain and the range? Another way to think about this is as a table. There are tables on your homework, and if I was going to make this a table, I'd have 3 and -4, -1 and 4, -2 and 6, 1 and 0. And of course, that's out of order, so that would need to be in order if it was going to be a table. But the answers are going to be the same. What's the domain? 3, -1, -2, and 1. In order would be -2, -1, 1, and 3. And the range would be -4, 0, 4, and 6. And that's just in order, but it's the same numbers. So when you get those problems on your homework where it's a table, the domain is just the x values, the range is just the y values. And same thing, if it's points, the domain is just the x values, the range are just the y values. One more I saw here I really wanted to do. It's this word problem down here. 21 or 22. So 22. Before a bowler, you guys know bowling. So we'll put the pins where you throw a big heavy ball down. Anyways, before a bowler rolls her first ball, 10 pins are standing. The number of pins that will be left standing, y, is a function of the number of pins knocked down. What is the range of this function? So we already told what the range is. The range is the number of pins still standing. Y is a function of the number of pins she knocks down. So y is going to be the number of pins still standing. So how many can still be standing? Well, there can be 10, 9, 8, 7, 6, 5, 4, 3, 2, or 1. Or there can be 0. She can knock them all down. That'd be a strike, which is very tough to do if you've ever been bowling. That's going to be my range. My domain in this position will be the number of times she throws the ball. And let's do 21. A student lives 3 miles from the library. He's riding his bike to the library. And just so you know, there's an R right there in the word library. It's not library. Library is not a word. Library is a word. You can always tell how much time someone has spent in a library depending on how they say the word library. A student lives 3 miles from the library. He's riding his bike to the library. The distance he has remaining, y, is a function of how long he has been riding his bike. What is the range? So if I was going to make this equation, x would be how long he has been riding his bike. Y would be how much time is, or how far he has to go. So I would not say he has to go either 1, 2, 3, or 4 miles, or even 0, 1, 2, 3, or 4 miles. That wouldn't make any sense to me because he could be 2.2 miles away, and that's not there. He could be 0.01 miles away, and that's not there. So I want to say the answer is going to be D. The range is all distances between 0 and 3. Because he can be 0.1 miles away, he could be 2.9 miles, he could just left, he could have been any number between 0 and 3. So that's going to be the end of domain and range. And I guess that's it. Bye bye now.